To evaluate the measurements made on an electrodiagnostic study, we must have the normal values or reference values. These values depend on the technique. For example, the distance used between the stimulating and recording electrode, which does vary among different laboratories. And therefore, you may want to make sure that your system is configured with proper reference values, the ones that are sent with your default settings. And if they are not, you may want to change them. So here is a step-by-step process to change the reference values. Click on System and then on Test Study Configuration. The reference values are mostly associated with the nerve conduction studies. Let's start with a sample motor nerve conduction study. Double-click on Motor NCS. Let's choose the median APB and then click on Edit Protocol. We'll click on Next. These are the amplifier settings, stimulator settings. These are some automation settings. And here is our table of stimulation sites. On the right hand side, we see a column for reference values. So the first stimulation site is wrist. And here is the segment associated with wrist. We are going to click on reference values. And we see a huge table. You can define reference values in a very complex manner that take into account the age, the height, distance, temperature. You can put in standard deviation, and you can also define the number of standard deviation limits that represent your normal or reference range. I'm going to show the simplistic way of putting a upper limit or lower limit. In the first two columns, we see LAT2 and LAT. LAT2 refers to the latency of marker number 2, which is associated with the peak. In motor nerve conduction, we measure onset latency. So that's this column. And I have defined an upper limit of 4.4. If I want to change it, just click it and type in the new value. For example, 4.2. Then we have a column amplitude 1-2. It represents the amplitude between markers 1 and 2, which is from baseline to the negative peak. So this is how we define the distal stimulation site normal values, the distal latency and distal amplitude. Those are the only measurements that are typically evaluated in a motor nerve conduction study. There are additional measurements available if you wanted to put reference values, for example, for area and duration or the relative amplitudes and so forth. But I'm going to illustrate only the minimum settings. Now when we come to the elbow setting, which is site number 2, and we come to the second row in the table, click on the reference values. This is where we usually do not have absolute limits for latency because they depend on the patient's height. Similarly to the amplitude, there are no normal limits, but we do have normal limits for velocity. So I'm going to scroll right, and here is the column for velocity. Again, the velocity can be measured using the onset marker or the peak marker, and hence we have two different columns. I have set up an upper limit of velocity to be 49 meters per second. And in the last column, you see amplitude 1-2%, which represents the amplitude drop going to the proximal site. And I have defined that anything more than 70% is normal. That is, the amplitude at the proximal site should be more than 70% of the distal site. And I can click on OK. And similarly, we can add reference values for the remaining sites. So this is the protocol for inputting reference values for a motor nerve conduction study. Sensory nerve conduction study will behave exactly the same way. I'm going to choose a median sensory nerve conduction, edit protocol, keep going next. Here are our sites, and when we come to the reference values, notice that we have defined reference values for the peak latency. You can define normal limits for the baseline to peak amplitude, amplitude 1-2, or peak to peak amplitude 2-3. Most laboratories will define the normal limits for only one of these two amplitudes, but the system will allow you to configure them for both amplitude measurements. And If you wanted, you could also define an upper limit for the onset latency also. If you wanted, you could also define the lower normal limits for the onset velocity and peak velocity. Let's look at F waves. Same strategy. In F waves, we can have automatic measurements, or we can have measurements that are based upon cursors. And this will depend on different instruments. So I usually define these limits for automatic and manual measurements. So for the automatic measurements, for the minimum F latency, I have set up a limit of 32. If I scroll on the right hand side, you can see under cursor 1, which is used for making manual measurements of F wave latency, I have set an upper limit of 32. And finally, let's look at the H reflex normal values. Again, I will go to the next. And just as in the F wave study, I have defined an upper limit of H latency. So that column would be used if we are using automatic measurements. In H reflex, if you wanted to use compensation based on H, certainly that can be set up, but that's beyond the scope of this current discussion. So in this manner, you can easily modify the reference values that are built into the system for the commonly tested nerves, and if you have all of those values readily available, it usually should not take more than 10 to 15 minutes. Having made all the changes, click on OK. The new settings will be applied from the next patient onwards.